In this section, we will explore NoSQL stores. The first question that we may have is, so what is NoSQL? You should understand NoSQL as not only SQL. It is a bit unfortunate name. You should better think of it as non-relational data stores. The reason is that some of these NoSQL stores actually have some version of SQL. These NoSQL stores have been created with the goal to address deficiencies of relational databases, and the NoSQL is an umbrella name for a variety of different technologies and approaches. One common thing is that they are non-relational and they are typically distributed data stores. Some of them are capable of executing MapReduce jobs so they can spread the processing over a number of machines, and that they are addressing the batch problem of plain Hadoop. So these databases will give us answers in real time. So let's imagine now that we are dealing with the world of relational databases. We can see that we are having great advances in capacity of disks and also in processors. Our CPUs are not getting that much faster, but we are able to deploy a larger number of them. And the processing power and the storage capacity is somewhat behaving linearly. So if I need 4 terabyte disk space, I would pay 2 times more than for the 2 terabyte hard drive space. So we have a fairly linear growth. Now, if you look into the relational databases, we see that it is relatively easy to start with smaller systems, but then as our appetite is growing, the cost that we have for relational databases is increasing. So we can say that when we are dealing with very large volumes, dealing with relational databases is going to be rather expensive and the performance is dropping. And we are also dealing with web scale problems where these volumes are simply out of reach of relational databases. So what we are trying to do with the NoSQL solutions are two things. First, we would like to get a linear response for the cost and performance of the system, and we would also like to allow for unlimited volume growth. We have seen that the unlimited volume growth was one of the primary goals for Apache Hadoop that we have explored in previous sections, and we are going to see how do we address the real-time capabilities with NoSQL stores. When it comes to processing, we have two approaches. One is the scale-up approach, which is commonly used with relational databases. In this approach, when you need more capability, you are getting a bigger and bigger computer. In the scale-out approach, you are running on relatively inexpensive machines, but you are going to use more of them. It turns out that scaling out is the optimal choice for growing our systems, and scaling out is the common approach that is used in a variety of the NoSQL systems, and we have seen that Hadoop is using the same approach. Typical NoSQL systems come in a variety of flavors, but they have common capabilities. So they tend to be non-relational systems. Most of them are distributed, they are horizontally scalable, and usually they don't need a fixed schema. You will find that you have a set of established players. There are always newcomers coming, so I recommend you to check every 6 months. There will be somebody new in the game offering some of the interesting new characteristics. And for many of these systems, you can say that they are specialized for a particular role, and you may choose among many systems with related capabilities. As we mentioned, many of these systems are running in a distributed environment, and there is something called the CAP theorem that describes the behavior of such systems. The CAP theorem is saying that at most 2 of the following 3 may be satisfied, and that are consistency, availability, and partition tolerance. And this theorem was established in 2000, proven in 2002. And think about our conventional systems. For example, relational databases don't have partition tolerance, but they have consistency and they are available. When we are working in a distributed setting, we are typically choosing the solution which is the eventual consistency. What that means is that in a distributed database, a value would need to be written at multiple locations to provide for fault tolerance. So we need to have multiple copies of data that will exist on multiple machines. And here we are facing 2 design choices. One choice is to lock the whole system until all nodes confirm that the data is written. We will be locking a set of machines in a distributed environment. We are going to have a rather poor performance that will not be acceptable to our users. The common choice is to allow reads to reflect values that are not necessarily the latest. So you may be returning some values that are somewhat stale. And we hope that this is going to be okay with our users. Now, when we say eventual consistency, that does not mean days or weeks. Eventually typically means milliseconds. But one of the big benefits is that our system is available and we are able to provide some response to the users. NoSQL stores come in several flavors. When we are working with a store, we need to choose a store that is going to be a good match for our application. Sometimes we are going to use several different stores that we may be using together, and this is something called polyglot persistence. There are 4 major flavors of these stores. We have a column family store. We have actually seen one of these as Apache HBase, which is running on top of Hadoop. The values are stored in columns, and the systems are good for storing sparse data. We have a document-oriented databases. Typically today, they will be storing data in JSON format or XML. Then we have a key value stores that act basically as distributed hash tables. And we have graph databases that can provide for representation of very complex data models containing relationships between many nodes. When we are selecting a database for our application, we need to think about the compromise between the scale and the complexity of data. So if we put these two as axes of our coordinate system, we see that key value stores can achieve the highest scalability. Apache Hadoop that we have seen earlier is an example of key value stores, but there are also stores that are specialized for non-batch, near real-time, and real-time capabilities. We have column family stores. They don't scale as much as key value stores, but they are dealing with a more complex data model. Then we have a document-oriented stores. The data models that we can store in JSON or XML are significantly more complex than what we can do with column families, but we don't scale as much. And then finally, we have graph databases, which typically don't scale as well as the other systems, but they can provide us with the most complex data model. The question is, what are the requirements of your application? You will find that if your data needs are not that extreme, you could use any of these systems to power most of your application. If you raise this bar, then you will see that you need to choose one or the other system, sometimes working together with alternative architecture to cover all the needs of your application.